Hello everyone, I welcome you all to this live session by Great Learning. Well, it's just 12 o'clock and we are supposed to start a day. And the best way to start your day is to learn something. And in today's particular session, we will be looking at the concepts of data mining, and we'll see how to implement those concepts with this awesome language called as Python. Now, before we start off with the session, just give me a quick confirmation if you can hear me. So just let me know in the chat if you can hear me properly and if you can see my screen. So if everything is proper, just give me a confirmation. You can keep writing yes in the chat window. So just quickly let me know if you can see my screen and also hear me. That would be amazing. And in the meanwhile, I'd like to tell you folks about this platform called as Great Learning Academy. So Great Learning Academy is a free initiative by Great Learning. And as you see over here, we have all of these live sessions which are scheduled. And the best part about Great Learning actually is that you have all of these different courses. So you can come to Great Learning, and if you want to learn data science, ML, cloud computing, marketing, big data, so whatever field you are interested in, you can just come over here and pick up any of these skills. And as I've told you, we also conduct regular live sessions. So if you want to see what are the next live sessions coming up, you can just check all of them over here. And when you enroll for any of these courses on Great Learning Academy, once you complete these courses, you will also get a course completion certificate. And you can add that course completion certificate onto your LinkedIn page or onto your resume. And that definitely will be a huge value add to you folks. So on that note, what we'll do is we'll go ahead and start off with today's session. So I see that there are a lot of yeses in the chat, which is great. Now, today's topic is data mining with Python. Let me just make this full screen. And before we start off, I see that there's a watching of 40 and we've got only 8 likes. Actually, we've got 10 likes. So if all of you could hit the like button, that would be amazing, right? So if all of you could hit the like button, and let's just get to 50 likes in the next 2 to 3 minutes, that would be awesome. And also, if any one of you are new to our channel, hit subscribe to our channel. Well, I'd request you folks to hit the subscribe button and also hit on the bell icon. So whenever you subscribe to our channel, you'll get notifications from our channel. So if you'd want to get updates on the new videos or on the live sessions, then please do subscribe. And also it would encourage us to come up with more such live sessions. So as you all know, we do not charge anything for our courses. We do it for you, right? Because we want everyone to get high quality education. And you can just shower your love by hitting the subscribe button. So we will go ahead and start off with today's session. When we talk about data mining, let's understand the first part of this. What is data? So if all of you in the chat could tell me, what do you understand by the term data, right? What exactly is this? What comes to your mind when you hear the word data? So I'll just wait for a couple of minutes over here for you to put that up in the chat. So there would be a delay of 10 to 15 seconds whenever we are live streaming. So if you are putting your answers in the chat, it would be take a bit of time for me to read your suggestions over here. So as I have asked you, what do you understand by the term data? So Vikas Gupta is saying data could be anything. Pratyusha is saying information. Well, that's interesting. So Pratyusha, now when you say data is information, you also need to tell me what is the difference between data and information. Venkat Ramna is saying facts. Yes. Tasha is saying information. Abhishek is saying some information. Kashyap Pandu is saying collection of facts, collection of information, meaningful information, processed information. All right. So all of you are saying data is information. Now I'd like to tell you folks that most of you are wrong. There's a difference between data and information. right? There's a very subtle difference, but you have to understand this difference properly. Now, whenever we talk about data, so as someone had said in the chat, data is just fact. So whatever is present around you, that is data, right? If you're working with numbers, that is data. If you're speaking something, that is data. If you look at an image, that is data. If you're watching a video, that is data. Now, it's not necessary that data has to be meaningful. It's just data, right? There is absolutely no requirement for data to be meaningful. And now the information between data and information is meaningful data is known as information, right? You can have data about anything and everything, right? So now let's say I'm just wearing a green shirt. Now this is not really useful information. This is just a fact, right? Me wearing a green color shirt is a fact. Now that doesn't have to be a meaningful information. So let's say if there's a direct correlation between me wearing a green shirt and let's say if I give the civil services exam today, right? So let's just say if I wear this green shirt, I am going to get first rank in civil services. Well, obviously that's not going to happen, I know. But let's just say there's a direct correlation. Now that is known as information, right? Me wearing a green colored shirt is just a random piece of data which will serve no useful purpose. But if it is actually, so let's say if there's a direct correlation, now understand this word properly. If there is a correlation between me wearing this shirt and me getting first rank in civil services, right? Now that is information because that is something new. You are finding out something new from the data or from the facts which you already have with you, right? Now, why are we talking about this data? Well, because back around 2 to 3 decades back, data which we had was very small. And since the data which we had was very small, we did not really think of using this data for anything insightful. Now, I believe most of you would have heard of this storage device called as floppy disk. So, maybe in early 1990s, we had a floppy disk, and at that point of time, the maximum storage capacity of a floppy disk was 512 kilobytes, right? So now we have phones and even iPods. So, I have this small iPod which has a capacity of 4 gigabytes. It's not much, but then again, it's only this much, right? It's a small iPod which has a storage capacity of 4 GB. Now imagine 20 years back you had a floppy disk whose storage space was only 512 kilobytes. Compare 512 kilobytes with 4 gigabytes. Now that's a huge difference in the amount of data present. And also it's not as if an iPod is much, its size is much higher. And so the iPod which I had was only this much, and floppy disk maybe it would even be of a bigger size than the iPod which I had. Right, so now you are able to store much large amounts of data in a smaller storage space. So data back then was very small, that is clear. And also data back then was very structured. Now what do I mean when I say data was structured? Well, data was mostly present in rows and columns, right? You did not have unstructured data because you did not have the social media boom or internet boom back then. You did not have sites such as Facebook or LinkedIn or MySpace or Instagram. Now you go to Facebook, a lot of people are uploading pictures. You go to Instagram, you have millions of pictures being uploaded every day. Similarly on YouTube, you have millions of videos being uploaded every single day, right? So all of this which you see on social media sites, that is unstructured data. Now if I just give you a simple data which is present in the form of rows and columns, that is known as structured data. So back around 2 to 3 decades back, since social media did not exist, data was very structured. And now after social media boomed up, right? After you have all of these social media platforms, data started increasing exponentially. You have data not just in gigabytes, you have every single day or even every single second exabytes or terabytes of data being uploaded or generated. whatever you do is generating data, right? You go to Amazon and buy something, that generates data. You make an online transaction, that generates data. You watch a video, that generates data. You upload a photo, that generates data. And all of this data, as I've told you, is unstructured. And now, if we are supposed to find out information from this huge amount of data, this is where data mining comes in, right? Now again, data mining is, now again you can use this interchangeably with data analytics or data science. So what are we doing? We have the raw data, and from that raw data we are mining out information, right? Understand this subtle difference between data and information. Data is raw. It's not necessary that data has to provide you any meaning, but the information which you extract from this data has to be meaningful. And what you're using to extract this information is called as data mining or data analytics or data science. So I hope everyone is clear till now. So again, just give me a quick confirmation if everything is fine. Pratyusha Mallila is saying, so data is knowledge. Yes, that is right. Data is just knowledge. Again, it's not necessary that it's meaningful knowledge, right? So let's say I've eaten a samosa today. It's just a very, I just have this knowledge of eating a samosa. Does it provide any information? No. But on the other hand, if I tell you the samosa which I ate, because of that, I put on maybe, I don't know, maybe it's some special kind of samosa and I suddenly put on 10 kgs of weight. That is information, and if I'm trying to reduce weight, then on the basis of that information, I will not eat another samosa. Right? It's a very lame example, I know, but this is how data and information works. Kashyap Pandu is saying mining out the knowledge, that is knowledge discovery. Yes, absolutely. So data is information in organized way. Well, it's actually the opposite way around. Information is data which is in unorganized manner, or information is basically where you have meaning in data. Great. So now that we are clear with this, let's go ahead and look at some use cases. Now we have this very simple example over here, which I give all throughout my live sessions and most of my tutorials. So you're just sitting at your home and you suddenly get a message or a call from your bank telling you that, boss, we've just seen a transaction made by you, and it seems that you have made a purchase of a diamond necklace in Australia and it is worth $5,000. Now you're absolutely shocked. So you're like, I've never made this purchase, I've never been to Australia, and I've never spent more than 1,000 rupees on my card. So, and I've never been to Australia and I've never made more than 1,000 rupees of purchase, how is it that so I'm very stingy, I don't like to spend money, so how is it that I go to Australia and buy $5,000 worth of diamond necklace? Well, I don't even have a wife, so why would I buy a diamond necklace, right? So that's absolutely stupid. And now I know that this is a fraudulent transaction, but how would the bank know that this is a fraudulent transaction? Well, this is because your bank employs certain machine learning algorithms, and these machine learning algorithms would actually track all of your transactions and they would keep a pattern of your spending. So this underlying ML algorithm would know what your spending pattern is. It would know that you have never purchased anything outside of India with this particular card, and you never spent more than 1,000 rupees at once with this particular card. So suddenly, when there's a transaction of $5,000, that too in Australia, and that too a diamond necklace. So let's say what your normal expenditure is mostly food, but suddenly you're buying a diamond necklace. Now this is very anomalous, right? So this ML algorithm identifies that this is an anomaly and immediately flags it, and your bank either calls you up or messages you asking you if this is actually a transaction made by you. So this is a very simple application of data science. And now that we know what exactly is the need of data science and we have looked at the use case of data science, let's look at the data science life cycle. And now we are faced with a lot of problem statements, and we have a lot of problem statements with us. Our first task would be to acquire data. Now, when we are acquiring data, you have to keep in mind that data comes from multiple sources and is present in multiple formats. So first, you go ahead and collect all of the data that is present, and you are collecting data with respect to the problem statement. And now, once you collect the data, your next task is to pre-process it, because the data which you have collected is probably raw, it is probably untidy. So you have to convert this raw data into tidy data. And now, once you convert your untidy data into tidy data, you can go ahead and build machine learning algorithms on top of it. Now, this is where, depending on the problem statement, you'll either use a clustering algorithm, classification algorithm, or maybe a regression algorithm. Now, after you build a machine learning algorithm, you'll get a result. And this is where you'd have to verify if the result which you get is actually correct or not. And this is known as pattern evaluation. And finally, when we know that the result is correct, we go ahead and represent our knowledge, or basically show our results in the form of beautiful graphs or dashboards. And this is the entire data science life cycle. Now, let's understand each of these stages in a better way or more comprehensively. This is data acquisition that we know, and I've told you that data comes from multiple sources and is present in multiple formats. So here, when data is present in multiple formats and is coming from multiple sources, you'd have to collect all of this data first and store it in one particular place, right? So let's say I have one data entry which is in the form of PDF. Next, I have a data point which is in the form of Excel. Next, I have something in the form of Word doc. So what I'll do is I'll collect all of these data items. I'll store them in my central storage repository, right? So normally this central storage repository would be your data warehouse. So I collect all of them, I store them in my data warehouse, and here there is something called as data integration. So what I do is, since all of these data items are present in different formats, and also since all of these are useful for my problem statement, I'd have to convert them into a single format. So this is, in the data warehouse, what I do is known as data integration. So I combine all of these different data items into one single data item. And again, from this one single data item, I'd have to select only those entries or those particular sets of information which would be very, very essential to my problem statement. So let's say after I integrate my data, I keep it in the form of a CSV file, and that CSV file has around 100 columns and 10,000 records. Now let's say out of those 100 columns or 100 factors, around 75 of them are important, right? So that 75 columns would be my target data, and that is what I'll be extracting. So I have acquired my data, and once I've acquired my data, this is where data pre-processing starts. So in the data pre-processing stage, I'd have to convert my untidy data into tidy data. So right now my data would have a lot of flaws. It would have missing values, it would have outliers, it would have anomalies, and a lot of other problems. And to convert my untidy data into tidy data, I'd have to use certain techniques, and those techniques normally fall under the purview of exploratory data analysis or data pre-processing. And also, when we talk about exploratory data analysis, so this helps us to understand our data in a better way. And here we use two different techniques. One is data manipulation and one is data visualization. Now let's understand data manipulation first. So we have acquired our data, and from this entire data set, let's say if you are supposed to find all those entries. So let's say in this data, in the CSV file, you have around 1 lakh records and maybe 10,000 columns. So from this data set of 1 lakh records and 10,000 columns, if you are supposed to find out all those people whose salary is greater than $100,000 and whose age is greater than 30, well, how are you going to do it? Well, you can't really go through every single record and check what is the salary of this person and what is the age of this person. And if you actually want to do it, well, no offense, but you would be very stupid to do it, right? So instead of going through every single record, you can just use certain EDA tools. And there you have languages such as Python and R. So with the help of Python and R, you can just write one line of code, and with that one line of code, you'll be able to extract all of the records where the salary would be greater than $100,000 and age would be greater than 30. Then let's talk about visualization. Now again, let's say I give you this huge Excel sheet, and if you just look at this Excel sheet, you'll not be able to find any information from this. But instead of giving you this Excel sheet, let's say I show you a pie chart or maybe a bar graph which is a representative of this Excel sheet, then you'll be able to find out insights from this. And this is why data visualization is also a very important tool. So we have acquired the data, we have converted the tidy data into untidy data, and we have done exploratory data analysis to understand the underlying structure of the data. Then once we know that we have the data to be proper, we can go ahead and apply any of our ML algorithms. And here the ML algorithm would depend on the problem statement. So let's say if your problem statement is a clustering related one, you can't go ahead and build a regression algorithm. Similarly, let's say if it's a classification problem statement, you can't go ahead and build a clustering algorithm. So you have to properly understand what the problem statement is, and depending on the problem statement, you will choose your ML algorithm. Now, once you apply your ML algorithm, you'll get a result. And this is not the end of your data science life cycle. And there is a very relevant reason why it's not the end. Because you've got the result, but it's not necessary that you've got an accurate result. Now, let's say if I'm giving an exam tomorrow, I'll definitely get a result. But I cannot be sure whether I will get a 90 on the exam or a 20 on the exam, right? So getting a 20 on the exam is not the same as getting a 90 on the exam. And if I get a 20 on the exam, I'd have to give the exam again. And this is what is known as pattern evaluation. You've built your model, but it's not necessary that you've got the accurate result. So you'd have to go back, tune your model or tweak your model, update your hyperparameters and build your model again, right? So this is a trial and error phase where you keep changing the hyperparameters of your model so that you get the best result. And once you get the best result, that is when you will know that this is my perfect model for this data. And once that is done, once you know that you've got the best possible accuracy, that is when you'll go ahead and show your results in the form of beautiful dashboards. And this is where you can use certain BI tools. So you can use BI tools such as Tableau and Power BI. And let's say if you just want to do it with Python, since you've done all of your EDA and applications of algorithms with Python, you can also use libraries such as Seaborn and Matplotlib to show your results in the form of beautiful graphs. Great. So we have also understood the data science lifecycle. Now, I'll again go back to chat and see if there are any more questions. Kashyap Pandu is asking, in data storage, big data concepts are involved. Well, that would depend on a lot of factors. Now, when you talk about data storage and also about big data, right? So what exactly is big data? Well, so your big data has to be present in a large amount. So let's say if your data is present in terabytes or exabytes, and also you are continuously getting this large amount of data, then you have this certain storage tool. Let's call it a storage tool. So you have this certain storage tool called as Hadoop, right? So you store your data in Hadoop. But let's say if your data is present in small quantities, let's say if I only have to deal with a small Excel sheet, or maybe it's a large Excel sheet whose size is around 5 MB, right? Would 5 MB considered as a large amount of data or big data? No. But still this 5 MB of Excel sheet would have lakhs of records and maybe thousands of columns, right? So this 5 MB of Excel sheet, you don't have to use Hadoop for this. You can use normal tools such as Python and R. So let's say where the data is present in gigabytes, or where there is a continuous flow of data, you can use your big data tools such as Hadoop and MapReduce. And also here you'd have to understand that Hadoop is for storing, MapReduce is for processing. Mayur is asking, can you tell about OLTP and OLAP? Sure. Let me explain it to you through some examples. So before that, let me tell you what is OLTP and OLAP. OLTP is online transactional processing. OLAP is online analytical processing. Now, when we talk about OLTP, right? So you can understand from the term itself. So these are day-to-day transactions, and this mostly deals with historical data. And when I say day-to-day transactions, you are not really finding out any information from the data, or you're not really trying to predict something from this, or you're not really trying to classify something. Now, let's say this is more of let's say data entry work and a small amount of data analysis. So let's say there's a shop, and in that shop you have the list of daily purchases and daily products sold, right? So maintaining all of these up, so let's say what were the products that were sold today, how much profit was done today, right? And what was the price of the maximum product that was sold, and let's say if there's an item X, how many items of this X were sold. All of this is OLTP. But what is OLAP? Where you're trying to find analytics. Now let's say if the problem statement is such that how can I increase the sales of my shop? Or let's say if I would want to find out if someone purchases a bottle of milk, what is the probability that he will also buy a bread packet along with it, right? So this is where OLAP comes in, where you're trying to find in analytics from your transactions which you have. So daily transactions, there is not much of analytics. OLAP, you're trying to find out new information from the data which you have. Nirbhay Singh is asking, are there any data mining courses on rate learning? Yes, we definitely have. So I'll just show you. Again, you have to understand that data mining is an interchangeable term, right? So data analytics, data mining, data science, you can probably interchange them, and depends on which area you're working upon, right? So if you, let's call this entire field as analytics. And if you want to get into the field of analytics, you can just browse through these courses over here. So we have this data science track, and if you want to get into the field of analytics, you can learn all of these things from the data science track, right? And most of these courses are with respect to R and SQL. Similarly, let's say if you want to get into the analytics track with the help of Python, you can go through all of these courses. Right. So we have looked at this. Now what we'll do is we will understand machine learning. So machine learning, again, to give you a brief intro, it's just an intelligent algorithm. And with the help of this intelligent algorithm, a machine can make decisions by itself. Right? Now, let's look at the categories of machine learning. So when we talk about the categories of machine learning, we have supervised learning and unsupervised learning. Well, we also have reinforcement learning, but then again, we'll not cover that today. So let's start off with supervised learning. And whenever we are dealing with data, we have something called as an independent variable and an dependent variable. So, or in other words, we have input variables and output variables. The input variables are represented with X, the output variables are represented with Y, and in supervised learning, we are basically trying to find out how does Y vary with X. So here Y is our dependent variable, X is the independent variable, and we are trying to understand how does dependent variable change with independent variable. And in supervised learning, again, we have regression and classification. Also, an important point to note over here is whenever it comes to supervised learning, your data is associated with labels. So let's say if I have an image of a car, that image of a car would have a label along with it, and that label would be CAR. Similarly, let's say if I have a column, and if that column has records or of the marks of the students, there will be a column name indicating MARKS, right? So your data points or your data entries will have labels associated with them when we talk about supervised learning. Right. Now let's start with the first one, which is classification. So classification is a supervised learning algorithm, and here we try to classify our data point in one of the categories. And since I'm trying to classify it into one of the categories, I'll have my dependent variable over here has to be categorical in nature. Let's take this example. So here I'm trying to understand if there's any relationship between smoking and cancer. So here cancer, so having cancer or no is my dependent variable, and smoking, so whether the person smokes or not, is the independent variable. So here what I want to understand is whether the person smokes or not. On the basis of that, I'd want to know whether this person will get cancer or not. And here, as you see, this is my dependent variable and this is categorical in nature, and on the basis of this I am trying to classify, again understand this, I am trying to classify whether this person has cancer or not, and hence this is a classification problem. So similarly we have regression. In regression, our dependent variable would be numerical. So in classification our dependent variable was categorical, but when it comes to regression, and especially linear regression, our dependent variable would be numerical in nature. And here we have the example over here. So let's say if I want to find a relationship between age of a person and salary of a person. So let's say on the x-axis I map the age of the person, and on the y-axis I map the salary of the person. And since salary is a continuous numerical, right? A salary is not a category. Salary is a continuous numerical. So here what I'm trying to do is, I'm trying to find out, let's say if the person's age increases, would the person's salary also increase? And according to whatever this particular data is, it seems that there's a linear relationship, which means that as the person's age increases, the person's salary would also increase. So that was supervised learning. Now let's understand about unsupervised learning. So when we talk about unsupervised learning, we have data with no class labels. So this is the difference between supervised learning and unsupervised learning. In supervised learning, we had data with class labels. In unsupervised learning, we have data without class labels. So here we have all of these entry points, and we are basically trying to understand what is the relationship between these entry points. And again, remember that there's no label associated with these. Now I go ahead and build an unsupervised learning algorithm on top of this. And this is basically a clustering algorithm. So when I build this clustering algorithm on top of this data, this clustering algorithm is able to divide this into two clusters or two groups. The first cluster comprises of all of the cars. The second cluster comprises of all of the bicycles. Now again, even though there are no data labels, right? So nothing is telling my ML algorithm over here that this is a car or this is a bicycle. There is no label over here. But even then it is able to cluster this. How is that possible? Well, an unsupervised learning algorithm tries to understand the underlying structure of the data. And here, this clustering algorithm has understood that all of these data points are similar. And again, these data points are similar. But when I compare these data points with these data points, they are very dissimilar, right? So in cluster 1, we have only cars. Now, here you'd have to understand two terms. One is known as intra-cluster similarity. Other is known as inter-cluster dissimilarity. So here all of the cars which I have, all of those cars are very similar to each other. And that is why there is high intra-cluster similarity. Again, all of the bicycles which I have over here, they are very similar to each other. And again, there is a high intra-cluster similarity. But when I compare these cars with these bicycles, they are very different, and there is very high inter-cluster dissimilarity. So the idea of this clustering algorithm is to basically make sure that similar items are grouped together and dissimilar items are mapped as far away from each other as possible. And this is the concept of unsupervised learning. So we have understood the basics of all of these. So again, I'll go back to the chat and see if there are any more questions over here. And now again folks, I see that there's a watching of 106 and we've got only 67 likes. Well, if you are finding the session to be insightful, don't be so stingy. Go ahead and hit the like button, right? It would help us a lot. It would also show that you like our sessions a lot. So go ahead and hit the like button right now, and let's actually reach 100 likes in the next 5 minutes. That would be amazing. And also, if you haven't hit subscribe to our channel, hit the subscribe button, also hit the bell icon. So whenever you hit the subscribe button, you'll get a notification of our upcoming videos. Please do not forget to subscribe, and please do not forget to like the video. And now let me see what are the new questions over here. Komal Dande is asking how to deal with outliers. That's a very good question. And now there are a lot of ways how you can deal with outliers. So let's just understand this concept of outlier. I'm not really sure how many of you know what an outlier is. So let me just give you an example. So let's just say there's a restaurant and the average salary of those people who go to this restaurant is, let's say, around rupees 10 lakhs per annum. Now suddenly one fine day, Mark Zuckerberg, Jeff Bezos, and let's say Elon Musk decide to go to this restaurant and have dinner, right? So suddenly the average salary of people who go to this restaurant shoots up. Initially it was 10 lakhs per annum, but since we have Elon Musk, Mark Zuckerberg and Bill Gates, right, the average salary suddenly shoots up. So from 10 lakhs it might probably go to 10 crores per annum. I'm not really sure how much do these guys earn, but it shoots up a lot. So over here, these three folks are your outliers. They are outliers because they have qualities which are not relevant to your data, right? Your data speaks something else, and these three people, their features are totally different. So that is why dealing with outliers is very important. Now there are a lot of ways how you can deal with data. First way is to just remove all of your outliers, right? So now, let's say if I remove Mark Zuckerberg, Jeff Bezos and Elon Musk from this, then I can get the proper high salary from this, or the proper average salary from this. But let's just say if my assumption or hypothesis was wrong. What if maybe these three people come to this restaurant regularly? So in that case, maybe I actually need to impute my outliers, or probably maybe reduce the effect of these outliers. So these are some things which you'll probably learn a lot in outlier analysis, and we might actually conduct another session on this. So if you want us to come up with a session on outlier analysis, just let us know in over here in the comment section after the live session, and we'll definitely take it up. Or maybe you can just let us know in any of our videos which you have uploaded. Suryakant Maske is asking, are there other algorithms in unsupervised learning? Yes. So there is something called as principal component analysis. And now, again, whenever you're building a model on top of data, you have to understand that your data has a lot of factors. And if I'm supposed to understand my data, I can only understand maybe 2D view or 3D view. Let's say if I plot something on XY axis. So if I plot something on XY axis, it is a 2D view. If I plot something on XYZ axis, it is a 3D view. But let's say if I have 10 independent variables, and if I want to understand how these 10 independent variables are affecting my one dependent variable, can I plot it somehow, or can I understand how these 10 independent variables affect my dependent variable? Well, this is where we have something called as principal component analysis. Again, we'll not go into the depth of this, so just understand that with the help of principal component analysis, we can deal with high dimensionality, right? When I say high dimensionality, let's say where we have a lot of factors, and we can reduce the number of dimensions, or we can reduce the number of factors. So when we reduce the number of factors, or when we reduce the number of dimensions, it is easier for us to understand the relationship between these independent variables, or how these independent variables are affecting the dependent variable. Alright, so all of our theoretical parts are done. Now what we are going to do is we will head to the Python part. So since today's session is called data mining with Python, we haven't yet done anything with Python, so let's go ahead and start off this task. Now again, a quick reminder to you folks. So let's say if you haven't yet liked the video, please do it. Well, again, I'd have to ask you to like this video, because if more of you like this video, more people would know that we are conducting this live session, and they can also learn something new on this day. Again, if you haven't yet subscribed, please also do subscribe to this channel. Do not forget to subscribe. Alright, so let's head to the Python part. Coding is important and we should not coding. So we have this FIFA dataset with us, and I'd want to understand some of the stats with all of the players associated over here. So my first task is to import all of the required libraries, importing pandas for data wrangling, and I'm importing matplotlib and cbol for visualization. So I'll click on run, and this will probably take a minute or two for these libraries to load up. And then in the meanwhile these libraries load, I'll also load my CSV file. So here the name of the file is players20.csv, and to load a file I'm using read_csv, and I am storing it in this object called as FIFA. And let me hit on run. Now again, since this all of these libraries are loading, it will take a bit of time. So I have also loaded the CSV file. Now after loading the CSV file, I would want to have a glance at the first 5 records of this. So I can just use the head method. So I'll have FIFA.head, and you see all of these columns are listed over here. So this is just the player ID for this FIFA data frame or data set. Then I have a URL, or probably a web page indicating all of the information for all of these players. So this is the URL for Lionel Messi, URL for Ronaldo, URL for Neymar, and so on. Then we've got the short name and long name of the player. El Messi, Cristiano Ronaldo, Neymar Jr. Again, we've got the long names over here. So if any one of you wants to know what is Cristiano Ronaldo's full name, well, here it is. It is Cristiano Ronaldo dos Santos Aveiro. And it is probably the first time even I'm looking at Ronaldo's full name. So this is quite interesting over here. And if I do want to know the age of all of these players, I have this particular column over here. I have the date of birth of these players. Then I have the height of these players in centimeters, the weight of these players in kilograms, and I have the nationality. So basically the country for which these players play, or basically the countries to which these players belong to. Right, so Lionel Messi is from Argentina, Ronaldo is from Portugal, Neymar is from Brazil, and I have also the clubs they play for. So Messi plays for Barcelona, Ronaldo plays for Juventus, Neymar plays for PSG. Right, so we have all of these different columns over here. So you see this dot dot dot. So this basically means that there are a lot of other columns as well. So I'd want to look at the names of all of the columns which are present in this data frame. And if I want to do that, I can just use a for loop. So here I'll write down for call in FIFA.columns. So for every entry in FIFA.columns, I'm going to print out call. So this will give me all of the column names which are present in this data frame. So you see that I have the list of all of the column names over here. Right, so I have the wage of the player, I have the player position, I have player tags, joined, loan from, dribbling, defending, physics. So these are the different columns which I have. So I'd want to know the exact number of records or rows and the exact number of columns which are present over here. So for that I can just use the shape method. So I'll write down FIFA.shape and I'll hit on run. So you would see that there are 18,278 records and 104 columns. So this would basically mean that there is information about 18,278 players in this data frame. Okay. Now this and this, we'll just remove it out. It does not really make much sense for us to dwell on this. So now I'd want to do certain exploratory data analysis. So from this entire data frame, I have this column called as nationality, and I basically want to understand in this data frame, how many of the players belong to which nationality, or I basically want to know what are the countries to which most players belong to. So for this, if I want a frequency count, I can just use the value counts method. So first I'll give in the name of the data frame, which is FIFA. Inside that, I'll give in the name of the column, which is nationality. Then I'll use value counts, and let me just hit on run over here. So you would see that, so out of the 18,000 players listed in this data frame, 1667 players belong to England. Then I have Germany. So 1216 players belong to Germany, then 1035 belong to Spain, 984 belong to France. Now similarly, let's say instead of all of this, if I want to look at only the top 10 countries having the most number of players in this data frame. So here the command will be the same, it's just that after this inside parenthesis, I'll give in this condition 0 to 10. So I'll have the top 10 countries with most number of players in this data frame. Right, so at the top I have England, and at the 10th position I have Netherlands with 416 players. Then similarly, let's say if I want only the top 5 countries over here, so I'll use 0 to 5. And you'd see I have England, Germany, Spain, France and Argentina. Now, this is only the raw information which I have, and this is in tabular format. I'd want to make a graph for this. So I'd want to make a bar plot where I have the names of the countries on the x-axis and the number of players for each country on the y-axis. So now whenever if you want to represent categorical data, I can use a bar plot. And to make a bar plot over here, I'd actually use matplotlib, and I've imported matplotlib above. So first I'll set the figure size. I'll have plt.figure, fig size is equal to 5,5. So the length and width I've just given it 5 over here. Then to make a bar plot, I'll use plt.bar, and inside this, remember that whenever you're making a bar plot with matplotlib, the first parameter should be categorical in nature, the second parameter should be numerical in nature. So here I have FIFA nationality.value count 0 to 5, right? So this command which you see, let me run this over here. So this command till here it is the same, but after this I'm using the keys method. So when I use the keys method, I get only this. So here I have keys and values. Now from these keys and values, I only want the keys because the first parameter needs to be categorical in nature. So the first parameter I pass in these values: England, Germany, Spain, France, Argentina. And in the second I want values. So if I want values, I can just pass in this and I'll get the values. And I'm setting a color for all of the bars over here, which would be green color. So I'll just set color is equal to G. Now when I run this, this is what I get. And it is very clear that the most number of players belonging to any country is England in this data frame. Then at the 5th position, I have Argentina. So see that there's a huge gap between England and other countries. So most of the players in this data frame, or majority, I wouldn't say most, but majority of the players are belonging to England. Alright, and now I'd want to do a different sort of analysis. So this time I'd actually want to see which of the players have the highest salaries. So from this FIFA data frame, I'll just go ahead and extract short name column and wage in euro column. Right, I have these two columns in my data frame. So from this I'm only extracting short name and wage in euro, and I'm storing that in player salary object. Now once I do that, let me have a look at the top 5 records. And here you see that I have these. So it seems that Lionel Messi gets a salary of 565,000 euros. Ronaldo gets 405,000 euros. Neymar gets 290,000 euros. But again, remember that this is not arranged in descending order. So it's not necessary that Lionel Messi gets the highest wage, right? So I'd want to arrange this in descending order so that I know who are the top 5 players with maximum wages. So what do? I go ahead. So this is the name of my data frame, player salary, and I sort this data frame with this column, which is wage in euro. So player salary dot sort values Buy is equal to wage in euro. So I am sorting this data frame with this column wage in euro, and I set ascending is equal to false, which would mean that I am sorting my data frame in descending order, and I store this in this new object called as player salary. So let me hit on run, and I look at the top 5 records of this. So you see that I have these 5 players and I have these 5 records, and I have the salaries along here. So it seems that Lionel Messi gets the highest wage. He gets a wage of 565,000 euros. Then we have Eden Hazard, and Hazard gets 470,000 euros. Then we have Ronaldo. Ronaldo gets 405,000 euros. Then Kevin De Bruyne. Kevin De Bruyne gets 370,000 euros. Then we have Griezmann. So Griezmann gets 370,000 euros. Now I have this data. Again, I want to arrange this data with a bar plot. So what do? Again, I'll set the figure size over here. So length is 8, width is 5. Then again in the bar plot, the first parameter needs to be categorical in nature. The second parameter needs to be numerical in nature. So here, categorical column is short name, numerical column is wage in euro. So I extract this column and put it as the first parameter. So player salary, short name 0 to 5. This is my first parameter. Similarly, player salary, wage in euro 0 to 5. That is my second parameter. Then I set different colors for all of the players. Lionel Messi gets a blue colored bar. Hazard gets a green colored bar. Ronaldo, red. Kevin De Bruyne, pink. Griezmann, orange. Let me run this and let's look at this result. Right, so I have top 5 players with the highest salaries, and this is the bar plot representing it. Right, so instead of looking at this data, if I just show this bar graph to someone, right, people would appreciate this bar plot much more than just a tabular data. Alright, now again let me head back to the chat and see if there are any more questions. Aditi is saying, I've recently opted for data science as an elective in my undergraduate degree, and I am very confused as where to start and what to start. Well, as a beginner in any field, you will have this dilemma of where to start and what to start. But it's actually good that you've taken the first step. Now, once you've decided that you've taken up data science as your elective, there are certain pillars of data science, right? The first pillar is statistics. Next pillar is programming. Next pillar is ML. Now, people have this misconception that stats and math is not important for data science, right? Remove this misconception out of your head. Focus on stats, focus on math, right? Focus on stats and math and improve your skills if you want to become a good data scientist. Then programming. When it comes to programming, there are 2 very important languages. One is Python, second is R. So use both of them properly. Then also we have ML, and so as a data scientist you would have to implement a lot of these ML algorithms. So you need to have a proper understanding of the concepts of algorithms such as linear regression, logistic regression, decision tree, and random forest. So master these 3 pillars and that would lay a solid foundation for you. Once you're good with these 3 pillars, you can go to sites such as Kaggle and participate in a lot of data science contests over there. So this should be a proper path for you. Pratyusha is asking, conceptual question, how would you train a model if the data that is given to you has extreme class imbalance? Would you synthesize data and feed to the model? Is it acceptable? Right, this is a very interesting question. Now, whenever you talk about imbalanced data, it is never recommended that you directly go ahead and build a model on it. So I'm not sure if you have heard of this technique called as SMOT. So SMOT is basically where we oversample our data. Right, now let's say our data is imbalanced. Now, to the folks who don't know what is balanced data and imbalanced data, when we basically talk about imbalanced data, so let's say if there are 2 categories, blue and red, right? Let's say there are 2 categories, blue and red, and there are 900 entry points of blue and only 100 entry points of red, and I'd have to classify it into blue or red. then there's a greater probability that I'll classify it into blue because my data is skewed towards blue. My data is imbalanced towards blue. So in that case, what I have to do is I'd have to sample up my data set. I'd have to make sure that the sample set which is for red is equal to the sample set which is for blue. So you can use different sampling techniques. Now, when I oversample my data of red, now what I do is, so let's say if there are 900 entry points of blue, I'd want to ensure that if not exactly 900 entry points, there are at least 800 or 700 entry points of red as well. Now, once you have a equal number of entry points or almost equal number of entry points, that is when you can go ahead and build your model. So I hope that answers your question, Pratyusha. Vikas Gupta is asking, is there any data science classroom program? Yes, we are starting up our classroom programs again. If you'd want to know more about our programs, actually, you can go to the Great Learning site. So I'll actually open up the Great Learning site over here. Let me just write in greatlearning.in. So if you want to enroll for a classroom program, you can just go to our site over here and check whatever courses are there. So this would be much more beneficial to you, right? So you have the digital campus, you have all of these different courses listed over here. You can just go and check it out over here. All right. Let me just see if there are any more questions. IITN Prashant Pandey saying, please make full video on web scraping using Python. So we have already uploaded a couple of videos on web scraping, right? I would have conducted 2 or 3 live sessions on web scraping. You can go through it. If you want a comprehensive video, that is also something which we can do, right? We'll definitely take down your suggestion and we'll come up with a video on that same. Twinkle Shah is asking, any React.js course? Well, we would have probably 1 or 2 hour course on React.js. You can just go to our YouTube channel and check it out. All right. So anyhow, folks, I guess we are done with today's time. We have comprehensively learned about some of the important fundamentals of data mining, and we have also learned how to implement these data mining concepts with Python. So this would be it from my side for today. Let's meet up in the next live session. Thank you very much and have a great learning.